now address the methods and procedure of this experiment. The goal of this experiment was to safely carry out the exothermic oxidation reduction single replacement reaction between iron 3 oxide and aluminum metal. The materials needed for this experiment include 1 flower pot, 100 grams of thermite mixture, 1 sparkler, a lighter, 4 cinder blocks, 5 bricks, and 2 metal plates. The first step in the procedure would be to set up the cinder blocks about as far as your metal plates will reach across, 2 stacked on top of each other. Then place the 2 metal plates across the cinder blocks. Finally, cover the hole in the bottom of the flower pot with a piece of tape and place in the middle of the metal plates. Then place the bricks around for safety reasons. Transfer the iron 3 oxide and aluminum powder into the pot. Light the sparkler and then ignite the iron 3 oxide and aluminum powder. Let the reaction proceed to completion. Then wait for the products to cool and clean up your... We will now address the safety concerns of this experiment. This reaction is very exothermic, so try to stay a safe distance away from the reaction. The reaction also produces ultraviolet light. Do not look directly at the experiment. Make sure to wear safety goggles and an apron while carrying out the experiment.
We will now address the learning concepts for this thermite reaction. Here again we have the equation for the reaction copied. Iron 3 oxide reacts with aluminum metal to form iron metal, aluminum oxide, and energy. In the single replacement reaction, the aluminum replaces the iron in the oxide compound due to the fact that aluminum is more reactive and higher up on the reactivity series. This reaction also represents an oxidation and reduction reaction. Here we already established the oxidation states for each of the elements in each compound. The oxygen in both cases is -2, so we hadn't recorded that on the board. But here, the iron starts the +3 charge in the compound with the oxygen. And then the aluminum is in its elemental form of 0. After the reaction proceeds, the iron now has an oxidation state of 0 as it's in its elemental form as a solid, and the aluminum has the +3 charge. Iron is reduced, the oxidation state decreases as the reaction proceeds, and aluminum is oxidized. The oxidation state increases as the reaction proceeds. This reaction also represents an exothermic reaction that releases energy in the form of heat and light. The activation energy must be overcome in order for this reaction to proceed. The activation energy is overcome by the ignition of the industrialized sparkler that is used to light the thermite mixture. Further, both reactants are in a powdered form. This is due to the fact that an increased surface area allows more exposure to oxygen and allows for the reaction to proceed more freely.
So before we did this experiment, we took the time to do a few calculations on the reaction itself. And the first one of those was to find the limiting reactant and what yield of iron we would get. So to do that, I used a sample of 100 grams of iron, 100 grams of iron 3 oxide, and we did a conversion factor to determine what our yield of iron would be in the end. And this first one, I did it with the iron 3 oxide as the reactant, and then the second one I used the aluminum. And with the iron 3 oxide, we got a yield of 70 grams of iron, and with the aluminum, we got a yield of 206.7 grams iron, which means that iron 3 oxide is the limiting reactant. So the next thing we did was to find the most efficient ratio of iron 3 oxide to aluminum. And we did that by basically going backwards. So we did a conversion factor, and we knew that 69.9 grams of iron, or roughly 70 grams of iron, were going to be produced. So we did that, and we set it over its molar mass, and then we compared it to how many moles are in the equation. So 2 moles of iron and 2 moles of aluminum, and then we multiplied that by aluminum's molar mass to get a to get a required amount of aluminum that would be 32.4 grams. And so then all we have to do is add up the iron 3 oxide and the aluminum. So 100 grams of iron 3 oxide plus roughly 30 grams of aluminum is going to be 130 grams of thermite in total. So then we divided our 100 grams of iron 3 oxide by 130 grams of the thermite to get 75.5% iron 3 oxide and 24.5% aluminum, which would be about the most efficient ratio of iron oxide to aluminum that you could use. And after that, we did a calculation to find out how much energy is released. And so in the equation, there is 849 kilojoules per mole of energy released from that equation. So 130 grams of our thermite mix would equal 69.9 grams of iron over its molar mass times 2 moles of iron, since there are 2 moles of iron produced in the equation. And then that is multiplied by 849 kilojoules per mole to give us 531.77 kilojoules of energy released.